a cloud formation so rare and so visually disturbing that meteorologists refused to officially classify it for decades. And the only reason it finally made it into the scientific record is because ordinary people started photographing it with their phones. Asperitas clouds look like the underside of a stormy ocean seen from below. Undulating, rolling, chaotic waves of cloud hanging overhead with a texture so alien that the first widespread photographs caused genuine confusion about whether they were real or digitally altered. They are real, and the story of how they went from being dismissed to earning their own classification in the International Cloud Atlas is one of the most unusual episodes in modern meteorology. Clouds have been formally classified since Luke Howard proposed his foundational system in 1803, which introduced the terms cumulus, stratus, cirrus, and nimbus. The World Meteorological Organization's International Cloud Atlas has been the official reference ever since, maintained and updated as understanding improves. For over a century, it remained relatively stable. New cloud types were not added casually. The bar was high. Asperitas first entered scientific attention through the Cloud Appreciation Society, a UK-based organization founded by Gavin Pretor-Pinney in 2004. In 2008, the Society began collecting photographs of an unusual undulating cloud formation that didn't fit cleanly into any existing classification. The images came from ordinary people across different countries, Iowa, New Zealand, the UK, all showing the same chaotic wave-like texture on the underside of cloud layers. Pretor-Pinney proposed the name Asperitas, from the Latin asper meaning rough or harsh, to the Cloud Appreciation Society, and subsequently lobbied the World Meteorological Organization for official recognition. The process took nearly a decade of documentation, atmospheric analysis, and scientific review. In 2017, the World Meteorological Organization officially added Asperitas to the International Cloud Atlas, the first new cloud formation type to be added since 1951. It was classified as a supplementary feature. Specifically, Asperitas is a well-defined wave-like structure in the underside of a cloud layer, more chaotic than undulatus clouds, giving the appearance of a rough, turbulent sea surface when viewed from below. Now to the science of how they form. Asperitas typically appears beneath altocumulus or stratocumulus cloud layers. The leading explanation involves Kelvin-Helmholtz instability, a fluid dynamics phenomenon that occurs when two fluids of different densities move at different velocities along their shared boundary. In the atmosphere, this happens when a layer of stable, moist air sits below drier, faster-moving air above. The velocity shear at the interface between the two air masses creates wave-like instabilities. When those waves form and the cloud layer is positioned at that boundary, the chaotic wave pattern becomes visible from below. The three-dimensional rolling and churning appearance comes from the fact that these instabilities do not form in a single direction. Multiple wave trains intersecting at different angles create the complex surface texture, peaks and troughs oriented differently across the cloud base, giving the formation its distinctly chaotic ocean surface look. What makes Asperitas genuinely rare rather than simply underobserved before smartphone cameras? The atmospheric conditions required are specific. You need a sufficiently moist layer to maintain cloud definition, while turbulent instability distorts it from above. The instability must be energetic enough to produce visible deformation, but not so violent that it mixes and destroys the cloud layer. The formation tends to occur in the aftermath of convective activity, after thunderstorms or near active weather fronts, when the atmosphere is still turbulent at mid-levels. The scientific value of Asperitas beyond its visual impact is that it is a visible marker of specific atmospheric dynamics. Its presence indicates Kelvin-Helmholtz instability at that altitude, which has implications for aircraft turbulence forecasting. Pilots and meteorologists can infer turbulent air conditions from the formation, even without instrument data. The fact that citizen photography drove the official scientific classification of a new cloud type is significant for another reason. It confirms that systematic global observation through distributed observers can contribute to formal science in ways that traditional research networks cannot replicate. Follow for more on the science hiding in plain sight above your head. And tell me, Asperitas was missed by professional meteorologists for decades until ordinary people photographed it. What else do you think might be sitting in citizen science data right now, waiting for someone to notice?